Okay. Hi everyone. My name is Isa Ali, and forgive me, but I'm not as YouTube savvy as many people out there. But I think this setup will work. My presentation is a case study on Staph aureus. Now, just a little bit of background. The reason why I chose Staph aureus is because the only time I have been hospitalized in my life has been because of an infection. And it was a Staph aureus infection. It was actually through an insect bite. I scratched it, at least that's what I thought it was, the route of entry. I went to a wedding, and overnight my hand swelled up. By the next morning, it did not dissipate at all, and I found myself running to the ER at Kings County Hospital Center in New York City. Initially at the ER, what they found was infection on my lymphatics, so it was a lymphangitis. It ran up my arm. The resident wanted to give me oral antibiotics and send me out. The attending then basically said, "Are you nuts? Do you not see it's actually in his lymphatics?" And she basically said, "Son, you're not going anywhere." And I stayed at the hospital for the night with vancomycin. So that's one of the reasons why I chose S. aureus, Staph aureus, because I had a personal run-in with this bacteria, and it was not fun. And it also introduced me to how serious things can turn. All right, so my case study is here on a 37-year-old African-American male. The patient was transferred from an outside hospital, and the only information that we have was he had some kind of mitral valve endocarditis. I'm going to get into what all this mitral valve endocarditis is, and there's a picture in there that's going to show you sort of like the anatomy of the heart valves, so it'll show you a little bit of what we're talking about. Patient history. Patient had quite a few comorbidities, diabetes, he had end-stage renal disease. He was definitely on long-term dialysis, and he had a prior, 4 months prior to his admission to the hospital, he had a bacteremic or bacteremia with MRSA resulted in vancomycin treatment. Okay, so that's some of his history. Currently, the patient was admitted with a temperature of 102 degrees. He had elevated white blood cells, of which 95% neutrophils, which are left shift. So he had a current infection somewhere along, he was spiking a fever because of it. Other things to note, he had a normocytic anemia, and his creatinine was much higher than what we ordinarily expect. However, both conditions were probably due to his chronic kidney disease. Okay, so when the patient was observed, he was observed to have a severe mitral valve regurgitation. This is when the blood flow is not normally going through the heart, through the chambers, and there is some sort of backflow. So that's what they call regurgitation. That's what my my research on this particular observation describes as. The picture here you will see is the vegetation. The actual bacteria itself is growing on the heart valve. And what that does is it causes an incomplete closure of that valve system. So there's always backflow of blood into the other chambers. They did an imaging testing which actually confirmed vegetation on the heart valve. And there were other complications which the patient had. He had osteomyelitis. He had subacute infections in the brain. The osteomyelitis I actually flagged because it could have been that the bacteria was systemic, so it eventually ended up in his bones. Just to review some of the Staph aureus lectures that we had in the class, it's one of the most clinically significant staphylococcus out there. Most of it is acquired through nosocomial infections. We're particularly interested because this particular staph has resistance to methicillin and vancomycin, which is pretty much the only two main antibiotics that we can treat these patients. This is a standard of care. Additional to this, Staph aureus also causes food poisoning, and enterotoxin, which means that the toxin is created within the small intestine, and it's a very difficult type of food poisoning to determine because there is no way to detect it. There's no you can't taste it, you can't smell it. So I thought I'd mention that because many of my case studies that I tried to look up for this Staph aureus bacteria, there were a lot of case studies in Brazil with thousands of people being affected by food poisoning, which I found quite interesting. And I wanted to present that. However, there were not any specific lab tests that I can actually show a proper case study on. Also mentioning that Staph aureus wound infections, pneumonia, bacteremia, and of course endocarditis. So in this particular scenario, the lab identification, what we had was we had the plating and isolation of the positive blood cultures. What we saw here was large white colonies showing gram-positive cocci in clusters. The article did mention a Molditov mass spectrophotometry performed for identification. I don't know why they went to that sort of length to determine what organism it was. It seems like mass spectrophotometries are very expensive and involved way to detect an organism, but I would have simply done some biochemical testing, of course, and then I probably would have done, a microscan. In any case, this is what the article determined was the course of action for testing. Okay, so after the organism was identified, one of the most interesting things that it did was it did susceptibility testing. And this is where things got pretty interesting. The preliminary testing showed resistance to some antibiotics, so cefoxitin and oxacillin, which was indicative of methicillin-resistant Staph aureus. Okay, an E-test was performed because the minimum inhibitory concentration value for vancomycin was higher than expected. So this is a much more precise way of measuring it. Repeat testing resulted in confirmation of something called vancomycin intermediate Staph aureus. And I'll explain to you the difference between methicillin resistant, vancomycin intermediate, vancomycin susceptible. It's on the next slide. Okay, so according to CSI standards, vancomycin and Staphylococcus aureus. So with the MIC results, less than or equals to 2 micrograms per is susceptible. Between 4 to 8 micrograms per milliliter is intermediate. And greater than or equal to 16 is resistant. So basically what we had here was we had an intermediate vancomycin resistant, vancomycin intermediate Staph aureus. Which is actually pretty interesting because it then shows you the various grades of resistance to vancomycin. And the next slide would show some of that. So, vancomycin, which is the standard of care, it's a gold standard, it's how we commonly treat these infections caused by methicillin-resistant Staph aureus. So vancomycin is really what many of the clinicians will be prescribing, and actually was one of the antibiotics, IV antibiotics that I was treated with. By the way, it's a very strong antibiotics. It's only administered by prescription in a hospital setting. It wipes out pretty much your entire stomach flora, I can tell you that much. Having been a patient in the hospital, it took me months, about close to 3 months, for my intestines and my GI tract to really get back to normal. I had to take probiotics, and pretty much every time I'd use the bathroom, it'd be very watery, very loose. All right, so it really affects you for a very long time. In any case, so VISA, which is vancomycin intermediate Staph aureus, okay, it was believed to be intermediate because of abnormally thickened peptidoglycan cell walls, and that is what makes it a little bit more resistant to vancomycin. Now, there was mention in this case study that because this patient had some sort of like prior infection, okay, this prior infection most likely would have caused higher resistance to the antibiotic. And although in this case study the patient MRSA, his isolate showed susceptibility to vancomycin, the elevated MIC results showed that the organism is acquiring resistance to vancomycin. The references for these are cited as such. And I would like to thank you guys for taking the time to listen to me. Appreciate it.